In this video, we're going to talk about practice problems for MTE 7, rational expressions and equations. I'm going to start off with the problem that asks us to identify all the x values that make the expression undefined, and they give us the expression x minus 3 divided by 4x minus 7. That expression is going to be undefined when the denominator is 0, so we're going to set 4x minus 7 equal to 0. Then we're going to solve for x by adding 7 to both sides. Then dividing both sides by 4. And we get x is equal to 7 over 4, which is the same as 1 3/4. I would leave it as an improper fraction here, though. So that is number 1. Number 2 asks us to do the same thing again, but the expression here is v minus 2 over v squared minus 7v plus 12. So we're going to have to factor first. Factor that denominator. V squared minus 7v plus 12, set it equal to 0. V, and we're going to have the signs are the same. They're both negative. And we're going to have 3 and 4 as our factors of 12 that add together to give me 7, but they're going to be negative 3 and negative 4, since it adds to give me negative 7. Set it equal to 0, then set each factor equal to 0. This is going to be an and statement. No, it's actually an or statement because I didn't make it not equal to. If I had said x can, or v cannot be equal to 3 and v cannot be equal to 4, that would be the domain here. But we'll just say v minus 3 equals 0 or v minus 4 equals 0, v equals 3 or v equals 4. And I can just write that as v equals 3, 4, like that. Or we can write it in set notation like this. Writing this one in set notation here, like that. Okay. Rewrite the expression without negative exponents. A to the negative 4th, b squared, c to the negative 2nd. So everything with a negative exponent is going to come to the denominator. I believe we talked about that in our MTE 6 video. That's it. It's just a refresher on what happens with negative exponents. Simplify the expression 2x minus 6 divided by 4x minus 12. I'm going to factor 2 times the quantity x minus 3 over 4 times the quantity x minus 3. We're going to be able to divide these out as long as x is not equal to 3. And when we do that, 2 goes into 4 2 times. So this is going to equal 1/2 as long as x is not equal to 3. When x is equal to 3, the expression is undefined because we would have gotten 0 over 0, and we don't know what that is. Now we're going to evaluate the expression here, p squared minus t squared over 4p plus 4t, given that p is equal to 2 and t is equal to negative 3. Okay, so 2 squared minus negative 3 squared over 4 times 2 plus, let's actually simplify this first before we start plugging in. This is going to be p plus t times p minus t over 4 times p plus t. P plus t, just so I make sure it's not 0, p plus t is going to be -1, right? So I can cancel that out. That's not part of my problem anymore. This is p minus t over 4. And so p minus t is 2 minus a -3 over 4. It's 2 plus 3 over 4 is 5 over 4. And I'm just going to leave that as an improper fraction. Now we're going to perform the indicated operation. We're going to add these fractions together, w over w squared minus 6w minus 7 plus a -7 over w squared minus 6w minus 7. So when we add the numerators together, we get w plus a -7, which is the same thing as w minus 7 over the common denominator of w squared minus 6w minus 7. Let's see if the denominator factors and gives me a w minus 7. W looks like it does. -7 and plus 1 multiply to give me -7 and add to give me -6. So I'm going to make those into a 1 as long as w is not equal to 7. This is going to be 1 over w plus 1. W cannot be equal to 7. Identify the least common denominator between 4 over x minus 2 and 6 over x plus 2. My LCD, because I don't know what x is going to have to be to multiply these two factors together and say that that's going to give me the least common denominator or least common multiple, right? Because I would have to multiply the top by and bottom here by x plus 2, and over here I'd have to multiply top and bottom by x minus 2. In fact, they're going to ask us to subtract those fractions right now that we found that common denominator. So I'm going to leave some space between them so I can write what my unit fraction is that I have to multiply by. In this case, I have to multiply by x plus 2 over x plus 2. In this case, it's x minus 2 over x minus 2. So this is going to be a common denominator of x minus 2, x plus 2. And the numerator is going to be 4 times x plus 2 minus 6 times x minus 2. This is going to be 4x plus 8 when I distribute this 4 over the parentheses. And this -6 distributed over the parentheses is -6x plus 12 over x minus 2 times x plus 2. Now I need to simplify that numerator. 4x minus 6x is a -2x. 8 plus 12 is 20. I need to demonstrate to my teacher that I know that neither x plus 2 nor x minus 2 are factors of -2x plus 20. So I'm going to factor out the greatest common factor of -2. And that leaves me with x minus 10 as a factor in the numerator. This is x minus 2 times x plus 2 in the denominator. And nothing cancels out in the numerator and denominator. So I am done. That's how we're going to simplify fractions. We're going to write them in completely factored form so that we see that everything has been canceled out, can be canceled out. Now we're going to add 1 divided by 7y plus 2 over 9y squared. So for the numerical part, I'm going to have to multiply by 9 over 9. And for the letter part here, I'm going to have to multiply by y over y to get a 63 y squared in my denominator is my common denominator. And then this fraction, I'm going to have to multiply by 7 over 7. So this can give me 9y plus 14 over 63 y squared. I don't have a greatest common factor in my numerator, so I'm done. Now they'd like me to add m plus 7 divided by m squared plus 7m plus 6 and 2m plus 1 divided by m squared plus 5m plus 4. Notice those denominators are different, so I'm going to have to factor them to let me see what the LCD is going to be. Maybe there's a repeating factor. Maybe there's not a repeating factor. This is going to be m plus 1 times m plus 6. This is going to be 2m plus 1 over m plus 1 times m plus 4. Let's go ahead and switch colors here for a second. That means that I'm going to have to multiply by m plus 4 over m plus 4 here. I'm going to have to multiply by m plus 6 over m plus 6 here. So that's going to leave me with m plus 4 times m plus 7, numerator here, plus 2m plus 1 times m plus 6, my numerator there, and my common denominator is going to be m plus 1 times m plus 6 times m plus 4. Now let's figure out what the numerator is, because I might actually get something where I have a factor of m plus 1, m plus 6, or m plus 4 when I'm done. It's going to be m squared plus 11m plus 28 plus 2m squared plus 12 plus 1 is plus 13m plus 6 over m plus 1, m plus 6, m plus 4. When we add together our like terms, we're going to have m squared plus 2m squared is 3m squared. 13m plus 11m is going to be 24m. And 28 plus 6 is going to give me 34 over m plus 1, m plus 6, m plus 4. Let's see, is that going to factor at all? Are there factors of 34, which are only 1 and 34, 2 and 17, that pair with factors of 3, which are only 1 and 3, to add together to give me 24 on the inside? Nope. 2 and 17 is close with 1 and 3, but no, that's not going to happen. 6 plus 17 is 23, not 24. So nope, this is prime. It's not going to factor at all. So we're done there. And if I want to prove that to you, I'd have to use techniques from MTE 9. So I am not going to do that with you right now. We'll talk about those quadratics like that, though, that we want to solve that are not factorable, and to prove that they have answers that have a square root in them when we get to Might even be an MTE 8 now that I think about it, since there's square roots in MTE 8. Number 11, x squared minus x over x squared minus 6x plus 8 times x minus 4 over x squared plus 4x divided by 4x over x squared minus 6x plus 8. I'm going to have to clear the screen here in just a second. I'm getting more writing than the whiteboard can keep up with. So sorry that it's thinking a little bit before it writes stuff on the board. X minus 2 and x minus 4. This is x minus 4. And this is x times x plus 4. This is divided by 4x over x minus 2, x minus 4. Okay, so this is going to be now I'm just going to write everything without any division. Sorry, I messed up my sign here. Let's go ahead and just clear the whole slide. All right. Sorry, everyone. Here we go. Now we're good. Start this one over. X squared minus x over x squared minus 6x plus 8, x minus 4, x squared plus 4x. We're going to change this division here in a second to multiplication before I start factoring. Times x squared minus 6x plus 8 over 4x. Okay, this whole thing and that whole thing make a 1 as long as we know that x squared minus 6x plus 8 is not equal to 0, which means that x cannot be equal to 2 and x cannot be equal to 4. All right, so we'll write that at the end. Now we have x times x minus 1 times x minus 4 over x times x plus 4. So the x's will cancel. X minus 4 and x plus 4, they're different numbers, right? So I'm going to leave this with x minus 1, x minus 4 over x plus 4 and x is not allowed to be equal to 2 or 4 because that would have made the original expression undefined. There we go. So number 12 asks us to find what 8 over 4 minus 5p minus 2 over 5p minus 4 plus p minus 4 over 5p squared plus 16p minus 16 is. Notice that everything else has p's written first other than this term. So I'm going to factor out the -1 from this term. I'm going to move it to the numerator. Okay, so move this negative to the numerator instead, so that I make it a -8 and a positive denominator down there. That's completely legal because -1 over 1 is the same as 1 over -1. So this is going to be equal to -8 over 5p minus 4 minus 2 over 5p minus 4 plus p minus 4 over 5p squared plus 16p minus 16. I'm going to combine these two. Now I'm going to factor the denominator down here. That's going to give me 5p. I assume I'm going to have a minus 4 with that and a p plus 4. It's going to give me 20 minus 4 is 16. So that means that I need to have my LCD of 5p minus 4 times p plus 4. I've got my 5p minus 4 on this side. So I need p plus 4 over p plus 4 is going to give me -10p minus 40 plus p minus 4 over 5p minus 4 p plus 4. That's going to give me -9p minus 44. It's a 9. 5p minus 4 p plus 4. We can pull that -1 out. It really won't do me any good to do that, but I'll pull it out. There is no other greatest common factor. 44 over 5p minus 4 p plus 4. And we have completely factored the numerator and denominator. Let's go ahead and delete that. Now we're going to take on number 13 and simplify. W over 6w minus 7, all divided by w squared over 12w minus 17. Remember that this is the same as w over 6w minus 7 with the divided by sign like this, w squared over 12w minus 17. So we're going to have w over 6w minus 7 times the reciprocal here is going to be 12w minus 17 over w squared. W is going to go into w squared w times. There's nothing to factor out of 12w minus 17 or 6w minus 7. So we're going to multiply straight across. The numerator is going to be 12w minus 17. The denominator is going to be w minus 6w minus 7. And we're done. 14 asks us to simplify w over w squared minus 6w minus 7 plus negative 7 over w squared minus 6w minus 7 over w squared minus 2w minus 3 minus 4 over w squared minus 2w minus 3. Okay, I have common denominators in the top and in the bottom already, so let's make single fractions. W minus 7 over w squared minus 6w minus 7. This can be divided by w minus 4 over w squared minus 2w minus 3. That's going to be w minus 7 over w minus 7, w plus 1 times w minus 4 is in the bottom here, w minus 3, w plus 1 is in the numerator here. When we multiply by the reciprocal of that, the w plus 1s will cancel. The w minus 7s here will cancel. And that'll leave me with w minus 3 over w minus 4. Remember that w cannot be equal to negative 1 or positive 7. The fraction would be undefined. I can't change my domain, which is the inputs that I'm allowed to put in, because I wasn't allowed to put in anything that would have given me 0 for any of the individual fractions or 0 for the entire denominator down here. So not allowed to divide by 0 anywhere in the problem. So not allowed to have negative 1, 4, or 7. There we go. Let's go ahead and just erase it. There we go. Now we're going to divide by the monomial here, and we did this before. We talked about when you are dividing by a monomial that you don't have to do any long division. You can just split it up like this. Did this when we talked about rules of exponents in MTE 6. So 18 divided by 3 is going to be 6. J to the 4 minus 1 is going to be j to the 3rd. 45 divided by 3 is 15 j. And we're going to have this was a 27, not a 25. 27 divided by 3 is 9. There we go. Up here. Everybody got that? But that was 27j, and 27 divided by 3 is 9. Use long division now to find the quotient. 20p to the 3rd plus 17p squared plus 26p plus 50 is going to be divided by 4p plus 5. So we're going to write 4p plus 5 as the divisor on the outside. We're going to write 20p cubed plus 17p squared plus 26p plus 50 as the dividend. We're looking for the quotient and the remainder, if there's a remainder. Hopefully there's no remainder. 4p goes into 20p to the 3rd, 5p squared times. Look at the p cubed minus divided by the p is going to give me a p squared term. And then 20 divided by 4 is going to give me 5. So that's how I'm going to get my 5p squared. I multiply back across. This gives me 20p cubed and it gives me 25p squared. Make sure you haven't missed any of the terms in the dividend here. If you have missing powers, go ahead and put a 0 coefficient as a placeholder there, because you want to be able to write your answer over top of the power. Now we had a positive and a positive, so when we add the opposite of a positive is a negative, and the opposite of a positive is a negative. So we'll change our signs and add. That first part is going to become a 0. That's what we want. When we add negative 25 to positive 17, we get negative 8. We're going to bring down. We're going to do this again. And we're going to divide p squared by p, and we get p. Negative 8 divided by 4 is negative 2. So we're going to have negative 8p squared minus 10p. We're going to change our signs and add. So that makes a 0. This is 36p, and we bring down. P goes into p one time. So we're just going to have our number part here. 36 divided by 4 is going to be 9. So this is 36p plus 45. Oh, I am going to have a remainder. That's okay. My positives become negatives. This is going to be 5. So I'm going to have a remainder of 5 over 4p plus 5. All right. If we had not had any remainder, it would have meant that this could have factored, and this denominator would have been one of the factors, and it would have canceled out. That's what that would have meant. But since we do have a remainder, then 4p plus 5 was not a factor of 20p cubed plus 17p squared plus 26p plus 50. Now we're going to solve the equation 4 over x minus 2 is equal to 1 plus 6 over x plus 2. Let's multiply everything here by the LCD. We're going to take note that x cannot have an answer of negative 2 or 2 because that would have made my denominator 0. So we're going to note the domain before we start off and change the problem. But I'm going to multiply everything by x plus 2, x minus 2. X plus 2, x minus 2. X plus 2, x minus 2. When I do that, the x minus 2's cancel here and leave me with 4 times x plus 2 is equal to x plus 2 times x minus 2 plus the x plus 2's cancel here, 6 times x minus 2. This is called clearing my fractions. It's allowed as long as I keep track of what x couldn't be originally, because I don't want to change the domain and get what's called an extraneous solution. So x squared minus 4 plus 6x minus 12. Now I'm going to get everything over to the x squared side. So I'm going to subtract 4x. I'm going to subtract 8. So I get 0 on this side. X squared plus 2x minus 20 minus 4 is negative 24. So let's factor x, and factors of 24 that have a difference of 2 are 6 and 4. The 6 needs to be positive, the 4 negative. So x plus 6 equals 0, or x minus 4 equals 0, x equals negative 6, or x equals positive 4. Neither of those are negative 2 or 2. We should go back and let's check our answers, though, to make sure that they actually work. That's something new with these rational, and when we get to MTE 8, the radical equations, is we should check our answers. So 4 over negative 6 minus 2 is 4 over negative 8. Is that equal to 1 plus 6 over negative 4? Let's see, it's negative 1/2. Is that equal to 2 over 2 minus 3 over 2? Negative 1/2 is equal to negative 1/2. So we're in good shape there. Just a second to bring my whiteboard back. sorry. And then let's check when x equals 4. 4 over 4 minus 2 is 2. 1 over 6 over 4 plus 2 is 6. Oh, this one's a lot easier. 2 is equal to 2. All right, let's clear this away. We got 2 true solutions to that one. I'm going to go ahead and I'm going to show you how you can do that without clearing the fractions and without changing the domain. It's very similar, just one step is different. So now I'm going to make common denominators. So my common denominator is going to be x plus 2 times x minus 2, x plus 2, x minus 2, x plus 2, x minus 2 times that 1. This is going to be x minus 2 times x minus 2. So the whole numerator is going to be the same as what I had just a minute ago. And the denominators are the same. I can, subtract one from the other now. Let's subtract this way so I make sure that I get the x squared. So 0 is going to be x minus x plus 2 times x minus 2 plus 6 times x minus 2 minus 4 times x plus 2 over the common denominator of x plus 2, x minus 2. And it's the same problem that I had just a minute ago when I ended up with x squared minus 4 plus 6x minus 12 minus 4x minus 8 over x plus 2 times x minus 2. It's going to be the numerator that has to be 0 here because I can't divide by 0 and get 0. I'm going to have to say that this is x squared plus 2x minus 24 over x plus 2 times x minus 2. And that was x plus 6, x minus 4 over x plus 2, x minus 2. I would have seen right away if anything canceled in the numerator or denominator that would have given me an extraneous solution here this way. I also see right away that my answers can't be 2 and negative 2, and they're not going to be. It's going to be x plus 6 equals 0, or x minus 4 equals 0, x equals negative 6, or x equals 4. The reason we like to clear the fractions is because the denominator is not really an important part of the problem here until the very end, and we check to make sure that we didn't violate the domain of the fraction by saying that the denominator couldn't be equal to 0. So really the numerator being 0 is the important part of the problem here, and that's what we focused on in the first method where we cleared the fractions. It's up to you which method you like more, which one your teacher likes more. All right, now we're going to do some the whole is equal to the sum of its parts problems. The current in the Red Cedar River is 6 miles per hour. So here's the river, and I'm going to say that this end here is downstream, and this end here is upstream, meaning that downstream is the direction that the current is flowing in, and it tells me that the current is 6 miles per hour. A canoe can travel 7 miles an hour downstream. Say downstream. Downstream with current, upstream, which is going to be against the current, I'm looking for what's going on with no current and still water in just a second. So we're going to look for distance, rate, and time. And it says that canoe can travel 7 miles downstream and the same amount of time that it takes it to travel 3 miles upstream. So times are equal. It's important. Our rate here is going to be it's the speed of the canoe, whatever it is, plus I have the current helping me. And we'll figure out in a minute what this is. And it says set up but do not solve. Use X as the rate. So we have distance is equal to rate times time. I need to solve for time since time is what is the same. So D1 over R1 is equal to D2 over R2. That means that 7 over X plus 6 needs to be equal to 3 over X minus 6. It tells us don't solve it, but it just wants us to set it up like this. This is the setup that it wanted. And so we're done with the problem there. If we would solve for X in this problem, X would be the speed at which the canoe would move in still water. Okay. Let's go ahead and clear that. A loaded moving truck is traveling 30 miles an hour faster than a freight train. And the time that it takes we're going to have distance, rate, time again. So we've got the moving truck. We've got the freight train. Distance, rate, and time again. And the rate of the freight train is slower, so I'm going to call it X. And I'm going to call the rate of the box truck X plus 30. And the time that it takes the train to travel 135 miles, the truck travels 225 miles, and it's the same time for both of them. Now, we already solved just a second ago that T is equal to D over R, but let's solve that again. So I'm going to have D1 over R1 is equal to D2 over R2 here. D1 is 225 over R1 is X plus 30, needs to be equal to 135 over X. We're going to cross multiply. 225X equals 135X plus 0, 15, 10, 4. So subtract 135X from both sides. And we get that 9. This is the same as 9 into 405. 9 goes into 40 4 times with 4 left over. 9 goes into 45 5 times. And X is equal to 45 miles per hour. That's the speed of the freight train. So this is going to be equal to 45 miles per hour. That means that 30 miles an hour faster means that the moving truck has to be moving at 75 miles per hour, probably speeding, most places in the United States, right? So it asks us to find the speed of the moving truck, and we found that X plus 30 was equal to 75 miles per hour. Now we're going to use proportions to help us estimate the number of fish in a lake. They actually do this with endangered species to estimate populations. So a ranger catches 220 fish and tags them and returns them to the lake. So later, 70, so we're going to let our proportion be the number tagged over the total number, right? So we're going to say that we don't know how many there are for the total number of fish in the lake, but we know that we tagged 220 fish in the lake to start off with, and that when we come back and catch fish later, that we caught 72 of them. 72 total, and 20 of them were tagged. And we're going to assume that that proportion is equivalent, that they spread out over the lake once we tag them, and that it's representative of the distribution of the entire population. So when we do that, we have 20 times x is equal to 220 times 72. I'm just going to leave that for a second. I'm going to divide by 20 here. 20 is going to go into 22 evenly and leave me with 11. So x is equal to 11 times 72. Multiplying by 11 is hard, but it's the same thing as multiplying by 10 and adding another one of them. So x is going to be equal to 792 fish. That's my approximation of how many fish are in the lake. If I tagged 220 of them and then went back and later, after I let them all spread out, and caught 72, and there were only 20 of them that had already been tagged, it looks like I had tagged this proportion of fish total. So that would give me that there were 792 total fish in the lake, approximately. It's my best guess. Source of heat A will melt heat source A. Heat source B, we're going to be asked about together. Okay, now this is not a distance, rate, time problem, but it's going to be similar because it's part of a job completed in a certain amount of time. So, time to complete the job, which is to melt the ice, alone is going to be, here is 2 hours. This is 5 hours. And this is what I don't know, right? That's what I'm trying to find out. So I'm going to call this unknown here X. And I'm going to say, okay, the hourly rate for each of these is that this one completes half the job in an hour. This one completes a fifth of the job in the hour. And likewise, this one completes 1 over X in an hour, right? And so my hourly rates should add together. My whole is equal to my sum of my parts. So I should be able to say that together they're getting the same amount of work done per hour as the individual components. We know that's not true necessarily, but that's the mathematical equation, is that we're going to have to say 1/2 plus 1/5 is going to be equal to 1 over X. And we say that the whole is equal to the sum of its parts. We're going to find a common denominator of 10 here. I say that this is multiplied by 5 over 5 and by 2 over 2 to give me the 5 plus 2 over 10 is equal to 1 over x. 7 over 10 is equal to x. I'm sorry, is equal to 1 over x. And so that means that x is going to have to be equal to 10 over 7, because I'm going to find the reciprocal of this number over here. And that is going to be 1 3/7 of an hour. We don't really measure in sevenths of an hour, but we might want to find the decimal approximation of that. 10 divided by 7. It's going to be 1 hour, and let's take that 1 hour away. Let's multiply by 60. So let's say it's about 1 hour, 26 minutes. Let's say that. Because we're going to want to talk in a way that people are going to understand our answer. So 1 hour, 25.7, we're going to round that to 26 minutes. It takes about an hour, 26 minutes. If we want to go all the way down to seconds, we can do that. So this would have been 1:25:43 then, if we go down to seconds, right? So there's hours and minutes, there's hours, minutes, and seconds, right? That's a very close estimate if we say 1:26:40 or 1:25:43. And that would be something that people could compare to these hours and say, yeah, it got done faster, both of them working together, than either of them getting done individually. I can see that, but it wasn't significantly faster than this one that was 2 hours that was slow. This 5 hours didn't really speed it up as much as probably we thought it would at first. Okay. I think yep, that's the last problem for MTE 7. We'll come back and talk about MTE 8 next time, which is going to be radical expressions and equations and radical exponents. All right. See you next time.